Hi everyone, I'm just gonna wait about 2 to 3 more minutes just in case there's some people trying to join, then we'll get started. I'm just gonna get started. I think whoever wanted to be here is here for now. So I'm gonna be actually going over survey analysis in R, and that involves cleaning data, putting it into an appropriate file, and then how you can manipulate it, make graphs out of it, and how you can analyze it. So I'm going to be going over survey creation, making your own survey, collecting the data for your survey. There's multiple ways of doing that. Cleansing the data, some important things to remember when you are cleansing data visualization, so how you would make graphs given the type of data that you have, parts of an actual statistical report, and how to put it all together in R. And then I will show you a report that I actually did for one of my courses this past summer. With if any of you guys were at the Women in Science Summit, we had a professor, Samantha Jo Cateno, there. She was actually the professor for one of the courses I took this summer, and it had to do a lot with generating statistical reports and survey analysis. So to start off, when you're creating a survey, you want to make sure that you have a clear goal in mind. If you don't have a clear goal in mind, you might end up going in circles trying to figure out what questions you can ask, how to display your survey, and things like that. The hardest part for me throughout this entire process was actually coming up with questions that are meaningful. So you don't want something redundant, and you don't want something where you're asking the same thing redundant, asking the same thing over and over again, or just asking something that pretty much doesn't give you any useful information when you're doing your actual analysis. Make sure that you're asking different types of questions. So a categorical a categorical data type is something like what kind of meals do you eat currently? Is it a lot of junk food? Is it a lot of healthy food? Is it fruits, vegetables, or is it just home cooked meals? A numerical data type is like, what is on a scale of 1 to 10, how active are you? So if I show you guys the survey that I created, you'll see that there's a good mix of categorical and numerical data. So physical activity before and after so my report actually focused on seeing if the pandemic affected people's physical activity. So because gyms closed down, there was a lot of things that were affecting people. No one had the motivation because of things happening, and etc. So so the first question is more of like a categorical question. It's a yes or no. How many hours a week did you spend participating in physical activity before and after COVID? This is more of a categorical question as well, even though it's a numerical input. If you think about it, this is because, say you have answers ranging from 0 to 5 hours. If you want to group people by, okay, who exercised 0 to 3 hours, that's category 1. Who exercised 3 to 5 hours, that's category 2. More than 5 hours, category 3. So there's still categorical data in that sense. How many meals did you eat on average before and after the COVID-19 pandemic started? This is a numerical input because people are just going to put, I ate 1, I ate 2, I ate 3. But again, if you want to manipulate it in a way where you want it to be categorical, so you have too many numerical values, then you can also do it by creating those categories like who ate 1 to 3, who ate 4 to 7, things like that. Next, another categorical one I had was what your meals mostly consist of. And I had weight ranges. So this could be a numerical value if you have people entering their exact weight. I didn't want putting in their exact weight because I know that's not a comfortable question to ask. So I was asking them weight ranges instead, and then and then I turned that into a categorical thing as well by grouping them by how much they gained or how much they lost or if they stayed the same. So again, if you look at these questions, they seem like pretty straightforward questions that you would think of right away when you think, okay, what would be impacted by lacking physical activity during the pandemic or continuing to be engaged in physical activity. But it actually took me quite a while to come up with meaningful questions that would give me appropriate data that I want to analyze. So next, when you're actually collecting your data, you want to make sure that you have your target audience in mind. I was mainly catering this towards young adults and university students, since I know that a lot of us had been affected by the pandemic in the sense of our classes usually, I know at UTSC at least, only a couple of them had web options. So most of us are usually going into campus, walking around across campus, and just that alone helped keep us, like, I guess, fit, not exactly fit, but help maintain our weight. But being at home, sitting at your desk all day for maybe 16, 18 hours a day because you're doing school full time and then you're studying after, that can take a toll on your activity. So mine was basically aimed at university kids and young adults. You also want to think of different ways to actually create your survey and how to store it. So I chose a Google form. Muffling my words. I chose a Google form because that was the most convenient and it gave me the data in a way that I wanted it. So if I show you guys how I actually got the data, it gave it to me in a CSV. I actually liked how so I kept it like this, and then in R itself, I went and removed some columns I didn't need, which I'll go over as well. But there are other methods that you could use to create a survey. You could use a Microsoft Forms. There's also SurveyMonkey. I'm not entirely sure how SurveyMonkey outputs its data sets, but again, like Google Sheets, you can export it into an Excel, you can export to a CSV, you can export into a tab separated value sheet. There's also just email lists. So instead of just having your data stored in the actual sheet itself, you would have a list of emails where the data set gets attached to the email itself, so per person. But the other thing you have to also keep in mind is that even though these may seem like good ways to do your surveys, there's also a drawback to every method that you use, which I will also go over in the final report. Another thing with email lists was, say you want to email out your survey to, say, everyone in York region or Toronto region. Another thing you have to keep in mind is something like, if I'm emailing it out to, what's the guarantee that I'm going to get a response from all 100 people? Some people might see it as spam and delete. Some people might see it as, I don't want to waste my time doing this. Like, I'm sure maybe your parents or even you have gotten those like calls where it's like, hey, do you want to take 10 minutes out of your day to do a survey? And I usually hang up right away. I'm guilty of that. But again, you have to keep that in consideration, because if you have nobody responding, then you're gonna have no data. So took care of that in my final report. You basically just kind of set a threshold for, if I get a certain number of responses, then that's fine. Otherwise, if I get less than, say, 10 responses, then I'm going to resample and get new emails and send it to the next 100 people, so on and so forth. Next, I'm going to go over data cleansing. Things you want to remember when you're cleansing your data is, don't keep unnecessary things in your data. If there are columns that are extra columns that you know you don't need and are not necessary, remove them. But the way you want to go about this is, don't manipulate your master data set. Create a copy or create a new variable that stores your data set with your edits made to it. So removing the unwanted columns, removing the unwanted rows, removing the NA values. Another thing you have to make sure of is that each column that you have is the correct data type. There may be some numerical columns you have that come up as a text, some numerical columns that you have as decimals, but they're showing up as ints or vice versa. Some time columns also show up as, number columns like ints or decimals. So just you have to make sure that your data types are consistent with what you want. Another thing is column names. So if I show you my data set here, my column names are the questions. If you want to refer back to this in R, it's going to be very, very annoying and very, not challenging, but it's going to take up a lot of your time because it's a giant sentence you're trying to put into the actual code, and you're going to have to reference that every time. So I'm just going to show you guys quickly how you could rename your columns here. So here, I'm just reading in the CSV, survey responses CSV. So let me just give you a quick tour of our studio. This is called an R markdown file. As you can see, I have a bunch of text and code embedded in it. This lets you generate reports with the most ease possible. So after you're done everything, you just click knit, HTML, Word, PDF. I usually do PDF. And it'll just, it's just running it because it's a bunch of code, but it'll put it on the screen. It's just running everything. There we go. So here, then you have your report outputted or anything you want. There's also ways to include your code. I haven't included any code in this because it was a report, but where it says include equals false, this you would just change to true. Then that would give you this entire chunk of code outputted as well. Just gonna rerun that, show you guys. So now you can see on page 4 here, this whole chunk of block of code where I was renaming everything. So again, see here, I renamed it to physical activity before pandemic, whereas it was an entire question, how much did you participate in physical activity? Just easier to reference later on when I need to do the data cleansing and manipulation. But yeah, so that's one thing there. I'm going to go over this whole thing in R again towards the end, after I kind of run through everything that we're covering. But yeah, and then another thing is adding weights to categorical data. So this is also something I did in my report. It basically just means, for example, that yes or no category, or the one where we had what kind of food have you been eating through the pandemic? It was home cooked, food from out, or I think it was junk food. I might be remembering the last one wrong, but that's when you want to perform numerical analysis on it or any type of analysis. It's not as easy to perform when you have text values as your answer, or text values as your data type. So you can take that data and actually turn it into numerical values. So say I associate the number 1 with eating homemade food, the number 2 with eating food out, and number 3 with eating junk food. If I want to average the number of if I want to get the average of which response was the most common, not most common, but if I want to average the results of all the responses, if I average homemade food plus food from out plus junk food, you can't really average text. So if I change that to a bunch of 1s plus add a bunch of 2s plus add a bunch of 3s and divide it by the number of responses, that'll give me the average that I want, and I'll see on average what type of food people eat have been eating before versus after the pandemic. The next thing is data visualization. These are just some common that are used in data analysis. There's line charts, bar charts, stack bar charts. You can see the difference between this is just instead of having it side by side, it's in one bullet bar chart. And the ones I've been using are charts and scatter charts. Sometimes column charts. Yeah, and line charts as well. Charts and stacked column volume that I've used, but pie charts are actually can also give of good useful information. Same with stack column volume. Just depends on how you're trying to display your data. So this is a table of how I go about picking what graph to use. So it depends on the number of data types you are trying to display in your graph or visualize. So if you have just one categorical value that you want to display, for example, the yes or no for did you participate in physical activity before the pandemic, that's just a categorical value of yes or no. That's one categorical and no numerical values. So I would have displayed that in a bar chart. If you have one numerical value, say only, I don't think I used a histogram in mine, but say you had just one numerical value, for example, what is your age? And you want the exact age values of, say, people, say you're doing like a heart disease study, and you're only getting a data set from people above the age of like 50, for example, and you want to know specific age groups, you would use a histogram. Two categoricals, group bar charts, one categorical, one numerical, side-by-side box plots. I'm not sure. I don't think there's a box plot on here. I can show you guys what that looks like because I know some of you may not have seen it. Just throw it into Google super quick. Box plot. This is what a box plot looks like. So these points on the top and bottom are outliers. You have your mean or average in the middle. And it shows you kind of like where most of your data is. So in this case, it's between the values of 60, just above 65 and about 65. And then we have two numerical values, a scatter plot, two categorical and one numerical, group box plots, and then one categorical and two numerical scatter plots with points identified by group. So that means you're grouping your scatter plots by color or by size, things like that. So I'm going to go over the parts of a statistical report. This is kind of like the bare bone template where you're not delving fully into the report itself. Sorry, not fully into the report itself. If you're not delving fully into the statistical side, you're more of like a beginner. So the bare minimum things you would want to include are what is the goal of your study, the procedure. So how are you going to go about collecting your data, running your survey, how you're going to cleanse your data or how you have cleansed your data, how you collected it, description of your variables or your columns. We also call and summaries, plots, graphs of all those, all the columns, so all the data have. This is basically the averaging that I was talking about, putting it into appropriate graphs to do further analysis and plots, things like that. Methods. So methods are actually like statistical techniques that you use to kind of see whether or not the hypothesis in the beginning. So in your goal, you should usually set a hypothesis that says, okay, I think what I'm trying to find is if COVID-19 affected weight or it didn't. I believe that it might have. We're going to delve further into this. Results actually are. So this testing down here will solidify my hypothesis in the beginning. I'll show you the t-test that I used. I know if you're not in stats and you're maybe in high school, you might not exactly know what that means, but again, I'll go over it in the report. So your results are going to be separate from your method section. The method section is going to be solely just doing the statistical method or technique and just the computational part. And then you have a separate section for your results that will go over everything you found in your method section. And then your conclusion will be there. So your actual, findings that derive from your data collection, your methods for the entire report. And remember to always include a bibliography because you want to cite any sources you may use. So if I just show you guys this report, I already had it open here. So this is the same report generated from this R markdown. I just want to show you guys this real quick before I jump back into the report. You don't always have to use an R Markdown. If you want to just do some code, you can do an R script. So you can literally just go, I don't know, just copy something from here. So like instead of doing these R blocks, if you want to add code into an R Markdown, it's adding this R block where you would go up here, add an R code chunk, or you could even add Bash, D3, Python, SQL. It's very easily integratable. So if you don't want to go through the hassle of that because all you're trying to do is add some code and run it and not actually write out a report, you can just simply do it in here, just type whatever you want. So if I want to just like do this here instead of putting in here, I could just, I don't have to put any quotes around it. I don't have to put it in a chunk or anything. It'll just run through here. It probably won't run right now because you have to save your files. So if you look in, move this over a bit because my other computer is blocking it. If we go into here, into here, let me just find it. Nope, one sec. Okay, I'm just gonna show you guys in my actual Finder. So if we go into here, this is where it was. So my survey responses are in the same location as my R Markdown, and my output that's generated will also be stored in that same location. So the reason this probably won't run right now is because one, I haven't saved the file, and two, my survey responses are not in the same location as where this untitled file is. Okay, now if we go back here, going over this report, I'm just gonna briefly run through it. The goal of my study was looking into the eating and exercise habits of individuals and honing in on their weight before versus during the pandemic. What are the uses of this study? Why is it relevant? How it can help? And a little bit of background research overall, because you want to also just remember that sometimes the audience or whoever reads your papers or looks at your statistical analysis might not know what you're talking about. Say maybe like 30 years from now, there's a stat student sitting in this seat looking at a paper you wrote. They found it on your GitHub and they're reading about COVID, but they never actually experienced it. So they'll look at this part and be like, what do you mean before versus after the pandemic? Like, what happened? So that's kind of where here I outlined that gyms were closed, things were we were on kind of lockdown, we weren't really allowed to go anywhere. So giving that background is pretty important to ensure that the person reading it has fair context. Next is a procedure. Again, this is just kind of outlining where I'm creating the survey, how I'm gonna go about it. And the drawback that I was mentioning earlier here. So another thing, yeah, so some people may enter emails that are not real or may not use them frequently. Since I'm only to one city or one age group, there might be a bias in regards to the data, because if you look at the GTA, for example, or I guess Southern Ontario as a whole, it's more diverse than, say, some parts of other parts. For example, Saskatchewan I don't think is as diverse, but the GTA and Toronto itself is a very diverse community. So based on that, it can also affect the data that you're getting back. I think later in this report, I also talk about how the South Asian community, I believe, the South Asian community, based on certain factors, they're actually a bit more prone to having higher health issues or health risks, which makes them more prone to COVID because their immune systems might be weaker, or even like males are also more prone to getting sick because I think there's a study on how males are more likely to get to be like smokers. There's all these studies that are researched, and that information to actually build my own report, which again is perfectly fine. You're allowed to do that as long as you're citing all your sources. Again, here, these up here are like embedded references. If I scroll, that's on number 5, if I scroll all the way down, that comes from this source here. Oh, not Wikipedia. Don't use Wikipedia. That was a bad source. I don't know why that's in there. But, or here, even number 6 here, this is just the name directory that I used for the email list. Just make sure you cite everything that you're using. Go back up here. I added a link to the survey just because our professor wanted that, but that's not something you have to include. This whole section you don't need to include either. This is just an explanation of 3 out of the, I think, 7 variables. Again, just something the professor wanted. Delve into the data collection. So I outlined that I have 12 questions, 5 categorical variables, 6 numerical. I talked about if I were to actually take this survey and conduct it in the real world and take it a step further, I would do it through, I would create a Google form and actually try to send it out to all Markham residents rather than just the community that I know, or rather than just the university students I know, and having them extend it to their families, because that's still somewhat of, I guess, not biased, but it does still skew your data because you don't have a diverse population set or a sample, sorry. Again, drawbacks that I mentioned before, the email situation. So a solution to this would be something like taking a 500 resident emails, sampling them without replacement means once you take that email, remove it from the list of emails that you have, because there's no point in selecting that email again. You're just not going to get a response again or something like that. Randomly, so we're going to randomly select those emails, send them out the link. If we receive less than a 10% response rate, so less than 10% of people from that 500 reply, repeat the process, sample again, 500 new people, and send them the survey again. So that'll ensure that I will have at least sufficient enough data to conduct my analysis. Next, data cleansing. So I explained how I removed the timestamp column because that didn't really have much relevance. It's here. Oh, it's here. So this column, see, it's showing it as a decimal number when I think it was when I converted it to a CSV. It started putting it into a decimal number. This is something that if I did need the timestamp column and I included it in my actual report, I would have had to figure out a workaround for this. But yeah, I just removed the timestamp column because the rest of them were actual survey questions that I needed. And then the next thing I did, I didn't actually have any NA or NaN values or empty cells, but I included this as a step because sometimes if you're looking at open source data, there might be NA values in it. That's actually something that I'll go over in another report that I did towards the end. You want to remove those NA values because they'll affect your graph creation and your actual analysis on the data. So it might just like cause errors, or your numbers will be skewed, and it'll just ruin your actual analysis and give you completely off results, or it might not even work. Next, what was this part? Yeah, so again, renaming, and yeah, that's still renaming, just kind of explaining to them like what BP, DP, HPW means. You want to be very thorough in your reports. That's one thing you'll notice as I'm going through this, because nobody can read your mind. I'm sitting here explaining this to you guys right now, but if I were to just throw my whole thing on a piece of paper with my graphs and not explain anything, it would not make as much sense. Next, you can actually put in different looking tables into your R markdown file. So this is just one style of table. So this is called cable tables. I'm just going to show you guys super quick. Yeah, I think this one shows it. Yeah, so here, there's different styles of tables you can have in R. So I think mine is just cable material. So it's this one down here. It didn't output exactly the same, but there's different type of tables you can use. This is from the cable package, Cable Extra. So these are the libraries that I import at the beginning. I usually like importing everything in the beginning because just makes it easier. I don't want to have to run this over and over again. So yeah, that's coming from this package here, Cable Extra. It's basically just the designs that you can use. And then if we go back, nope, here. Okay, so this is just going over all of the variables I have. Like I said earlier, you want to give a description of all the variables that you'll be using throughout your report. So again, the reader has context of what exactly you're doing. Doesn't have to be a long example. It's literally one sentence, and I threw in a small example. You'll see that most of it is pretty repetitive with like 2-3 things changed, but it's better to have this than have nothing. So next we have numerical summaries and plots. So this is where I was talking about the yes and no for physical activity. If I wanted to get the average number of responses for who was physically active and who wasn't, and see where that number lies, I wouldn't be able to do that if I had just yes and no values. So let me just go to the part where I turned it into, or I assigned it the numerical. So here, physical activity, assigning weights. Physical activity before the pandemic, I just did an if-else statement where if the physical activity before is yes, then assign it a 1, otherwise assign it a 0. So then when I took the mean of this, I got 0.906. That the average number of people that were physically active before the pandemic is closer to 1, meaning most people that did the survey were physically active before the pandemic. Min-max values didn't have much relevance here. Again, I included most of these things because my professor wanted it, but in an actual statistical report, if your min-max values don't tell you much, you don't really need them there. Median value, that's standard deviation, interquartile range. The standard deviation just tells you how spread out your data is from the center. The center would be around your mean. Again, this is very statistical. These are very statistical terms, which you might not know right now. But if you're interested in stats, then and you go down that route, or if you're already in that route, you would know. But if you're interested in going down that route, then you would learn what all of this stuff means. Okay, and then just like I had a do all your analysis and add your graphs, make sure you always add like a little blurb at the bottom to kind of explain your findings, because physical activity before and during. I threw it into a bar graph. Again, there was only one categorical data value. So here you can see before COVID, there were almost 30 people participating in physical activity. And then during COVID, that number dropped to just above 20. So let's say 5 to 7 to 8, or maybe even 8 people is where the data differentiated. Same thing here, the number spiked from maybe, let's say, 2 or 3 to 10. And then eating habits. I'm not going to go through every single variable. I'm just going to kind of skim through it. I'll tell you guys the means again. So the mean is 8, which is close to, let me see what I assigned these. Eating habits here. So 1 homemade meals, 2 snacks, 3 takeout meals. This is another way of doing it. RV is just random variable. My variable name was meal type, which I renamed it above. And then as numeric just assigns, it just assigns categorical value, a number. I believe it just does it alphabetically. So there's no 3 is not better than 1 or 2 is not better than 3. Like they're just randomly assigned. They don't hold much meaning. It just gives us more meaning when we're finding things like the mean. This tells us that most people were eating homemade meals since it's close to 1. If it was like 2.7, then it would be a lot of people are eating takeout meals because that would be closer to 3. Again, just put that into a graph. I put the eating habits during COVID into a graph. Types of meals, again, put that into a graph again. So our mean that we got, which is homemade meals, aligns with the graph that we have, showing us that most people are eating homemade meals. Weight change during COVID. I'll just go over this as well because it's the whole changing categorical into weights. So we see that a mean is 2.84, which is close to 3. If I go here, I see 3 means many people gained 21 to 30 pounds during the pandemic. And that could be a direct result of what we saw up here, where we saw that the number jumped from about 2 to 3 to 10 people that are no longer as active as they used to be. Keep going down. See this, 1 second. Yeah, sorry, the average number of people were lost that much, but the largest number of people lost 1 to 10 pounds. So that still is a pretty big, I guess, discovery, you could call it, because just this alone tells us that, okay, this could be, emphasis on the could, because we don't have solid proof just yet until we do our hypothesis testing, but this could be a reason as to, this could be a direct result of the fact that people aren't going to aren't being as physically active anymore. And here, average participation in physical activity, which is just trying to find what number it aligns with. Actually, no, this was a numerical value. So 6.25. So on average, before, people spent 6.25 hours being physically active. And then during the pandemic, it was 3.25. So it was almost cut in half. If we go down here, again, if you look at the during COVID, that's from here back. People were, during COVID, the graph actually shifted back from max being 15 hours to it being 10 hours. So already there's a 5-hour difference shift. You can also see that the values were very much more spread out before COVID. There weren't as tall bars. They were more so evenly, or not evenly, but there is normally distributed almost. Normal distribution is like the bell curve, which is like, just over here, there were some values that threw that off. But if you look at the during, have a spike in the number of people who are not being physically active at all. So that's around 8, which also aligns with the number of people we saw that were not active after the pandemic. Average number of meals eaten per day. So this isn't too much of a difference. Here we had 2.72. Here we had 3.28. That just tells us most people were having around 3 meals. So that didn't really change. The biggest part was probably physical activity. Again, here, not too big of a difference. The only thing COVID is no one was really eating 1 meal anymore. More people started eating 2, and there were a couple people that started eating 5. So this could actually also be a direct correlation to all our other findings. And then here again, so we have the mean weight. We had 144.5 pounds before the pandemic, and then after we had 153, which also aligns with our finding of people gaining around 1 to 10 pounds. And then, so this is just, again, the same graph, weight in pounds during. So I did the numerical measures. These are called numerical measures, the mean, min, max, median. The median just tells us what's the middle number in the entire data. So it'll sort it by largest to greatest, and it'll take the number right in the middle of the data set. So that was just 157. And then, so then I would just take the numerical measure data, same data, and throw it into. You don't have to do this for every single data variable that you have. I'll also show you that in my final report, because I've made a lot of changes after I was doing it. Here's the method. Again, a lot of this might not make sense to you. It's a lot of statistics and numbers and formulas that just might not make sense, but I'll just show you guys the results and what they basically tell us. So this t-test value, so here I'm comparing, it's a couple months ago, so it's a little not as fresh in my mind, but I'm comparing. Let me just double check up here. Okay, so I'm comparing the average amount of time of physical activity before and after the pandemic. And value, which is this.
Thus, the test we're performing.
It's
the p-value.
We can safely conclude that the pandemic did significantly affect, on average, physical activity before that pandemic was affected when compared to physical activity during the pandemic. And then another thing here, the 95% confidence interval, which is the two outputs down here, since it doesn't contain 0, then we can also tell them that physical activity before the COVID-19 pandemic decreased by around 1.62 to 4.38, a unit of 1.6 to 4.38. Same thing here. This is just comparing. One second, just trying to find it. The weight of people before and after the pandemic. So it's telling us, is there a correlation between weight before and weight after? Again, there is, because the t-test value here, 4.91, is greater than the p-value here. And again, since 0 is not included in our lower and upper bound, that means that that the weight of individuals the weight of individuals during the COVID-19 pandemic may have decreased by a unit of 5, up to 5 pounds, but it also increased up to 12 pounds. And then we just have our conclusion where I'm tying everything together and talking about how, from all my findings, it does seem like the pandemic may have affected people's weight as a result of lack of physical activity. And it's just kind of what that goes over. I'm going to go back into the R Studio file and just quickly skim over this with you guys. Also, if you have any questions, just feel free to message them in the chat. I'm not sure if there's nothing there yet, but if you do have questions, feel free to message them in the chat, and I can try to answer them to the best of my ability. I'm just going to make this a bit bigger. So I'm just going to clean this up, show you guys this side as well. So this is not how our studio is like auto set up. This is kind of how I have it set up. So I have my coding here, my environment. This is usually on the bottom, and the console is usually very customizable. Usually it's a white screen. I changed it to a darker view because it's just how I like it. So again, this new page just pushes your things to literally a new page. Again, just text. This is how you embed links. So you'll notice that I have the link pasted twice. This just puts the link into it. This part actually makes it clickable in your output file. So if it's a PDF or a Word file or HTML, that's just how to bold it. These hashtags are just, they make the headings. The more hashtags you add, the smaller the heading will get. Same thing here, hashtags that, and then R block. Just gonna go over this again. Renaming variables. I actually put the NA omit here, so that's how you would that's how you would get rid of the NA values in your data set. And as I mentioned before, you don't want to store your data, your modified data. You don't want to write that directly to your initial data set, your master data set. So here I created a new variable here, and that's where I did all my manipulation. So I renamed it in the new variable, and then I removed the timestamp column. So it's just take the subset of my survey up here, which I renamed, and select everything, but disclude the timestamp. So minus timestamp. Here I'm just resetting new variables because I didn't want to type out physical activity BP. I just I shortened it to the variables, and I referred them to each column. Now, if you want to refer to the data, a specific column in the data, you would just do data set name, $, quotation, single quotes, the name of that variable or the column. But since I renamed them up here, just using the rename function, I don't have to type out the entire question. Another thing, this is called piping. So what piping basically does is this could just be two functions. I could do survey data is new data, and then in another line I could just do survey data new and do that and just get rid of this. What it essentially does is it allows you to perform multiple operations in one go rather than having that, I guess, the redundant several lines of code and having to copy paste this a million times. The weights assigned here, I went over those. This is how you create the table. So I first, with my column names for the table as variable, type, and description. Let me open the report here as well so I can show you as I'm going through it. Here, so we have variable, type, description. And then again, it's just all I typed it out by hand. And then this is the part that actually puts it into a table. So I want it to be the full width of the page, center of the page, 3 columns, and that's just how you would define the sizing. And then, sorry, wrong thing. And then here I'm just doing all my numerical analysis. So taking the mean, again, these are all built in to R, like mean is built into R. Sorry, I got confused. I'm like, why are there 2 means? Okay, mean is built into R, median, deviation, minimum, maximum. They're all built-in functions. You don't have to import any libraries for these. For IQR, so interquartile range, you actually had to import stats. That's not a built-in function, but again, they're very accessible, not too difficult at all. It makes your life much easier than having to sit down and do everything by hand. Again, here, this is just creating the tables that I had here, these ones. Again, I'm just throwing in, I'm referencing instead of doing it by hand, which were defined up here. And if we go down, these are how you make the graphs. So this is the bar chart. So ggplot is, you don't have to use ggplot. Again, it's another library. It just makes your visuals look prettier. That's literally all it is. So for example, like these colors that I threw in here, just the way the graph looks, that's what ggplot just gives you a better visual. But there are like base R commands that you could also use. I think it's just literally just plot. But yeah, so here I'm taking in my data. My x-axis is my variables yes and no. And then here I'm actually defining the colors over here, values. Again, built-in colors, navy, dark orange, just retitling things. And yeah, so if we keep going down, I think all of these are bar charts. So yeah, there's not too much different here. Let's keep going down. So I'm gonna go over, okay, so this is including inline R code. So for example, the mean weight change, let me see what this is. Change in weight during COVID pandemic. Let me find it. Probably not. Okay, let's just scroll through this real quick. See if I can find a value for you guys super quick. So here, 6.25. This 6.25 is coming directly from here. Average E. It's on E. So it's the first one. Yep. So mean average physical activity before 6.25 hours. You can see it's directly coming from up here. I just threw in the variable name again, mean average physical activity before. Or no, I think that, yeah, I defined that above when I was calculating the. So again, it's also up here. You can just, instead of having to type out the numbers by hand, because sometimes you have really like whack. So if I scroll down here, like here, right here, 4.158. I don't want to memorize that. I don't want to look back and forth. I can just do inline R referencing. Keep going down. There's not too much else to go over in terms of this report. I can show you how to throw in formulas like this. LaTeX tool to have, because R actually using LaTeX similar commands or ways of doing things. If I go to my t-test, so here, these dollar signs just mean I'm inputting a formula now. So H_0, that gives you the subscript. And if you hover over it, it'll show you what it'll look like. Mu, again, that's how you get your mu value. Subscript is _1, mu2. I'm gonna look for a more complicated one. So here, if we look at just hypothesis formula here, you zoom in on that so you guys can see it. It's not working. Cooperate. Okay, I lied. It's not letting me zoom in. My thing is messed up. Okay, so if we look at this formula here, it's a fraction. You can't just throw the fraction wherever you want. You're gonna have to start it off at, so t equals, I have a fraction, x bar subscript diff. So bar of x underscore diff minus 0, and then my second part of so your first part of the fraction in squiggly brackets, second part of the fraction in a set of different squiggly brackets. So s underscore of x. And again, if you're not sure and you don't want to knit everything, you can just hover over it. It'll show you what it'll output. I was getting quite a few here because of I think I was getting errors here because the formula was quite long. It gets kind of complicated, but there's a lot of documentation on this online. There's not much else in here. Yeah, just the bibliography again, how to Google links. Go back here. You can also use Jupyter Hub. So RStudio Cloud. What Jupyter Hub gives you is a cloud version of. There's also RStudio Cloud. That's a separate thing, but Jupyter Hub is offered through U of T. If you go to U of T, so I used it through U of T. Have your email. I'm not sure if other universities provide this, but I know U of T does. You just log in with your credentials and you get access to Jupyter Hub. And again, you can code in any language in Jupyter Hub. I've done Python before, Java, literally anything. But our professor actually would give us the files on Jupyter Hub. So she would upload her starter code to Jupyter Hub, and we would have access to it through this. So this is where I used to initially do my assignments. And then I moved them over to my personal because I just liked coding in here better. So there's also many different accessible tools. So I just showed you guys this one, my first assignment. I'm gonna just do a quick skim of my other analysis I did. So this one was case types, which case types are more important during the COVID-19 pandemic. So we had travel-related incidents, outbreak, close contact exposure. Again, you'll see the difference here is that I have an abstract now instead of just a general goal. This abstract outlines your entire report. So this is the thing that you would put in last. But again, it outlines the whole report. So what you're testing and then just a brief overview of your results. So for example, here we were able to conclude close contact cases were most concerned. You're not hiding anything from the audience. You're giving a overview of the whole report and what they can expect. Again, intro, same thing, bit of background information, a table for your variables. So I only had 2, 4, 5 here. You'll see there's a lot of text because there's a lot of research that goes into actually having a good report that's strong. Again, I'm giving a breakdown of the variables I had and what kind they were. I went into the details of what happened with my data. So the issue with the data I had here, let me see if I think I have a link in here. I can find it. But the issue with the data that I had here was I had a data set of COVID cases all across Canada, so all the provinces. But when I filtered them based on certain things, so I think I filtered them here. I believe I filtered them based on having no NA values in the, back to the variables. So there were no NA values for the outbreak. There were no NA values for close contact and travel related. So I wanted provinces that had data for all 3 of these case types, because if I didn't, again, then it would skew my data set. But when I applied those filters, I was only left with data for, I think, Ontario, which I guess ended up being bit convenient, but at the same time wasn't exactly what I wanted to get out of it. But that's okay as long as you have to outline all your challenges and things in your report, and then go to the data cleansing, data descriptions. Again, you'll see here I don't have graphs for everything. So this is just going over me assigning weights again. So this is one of the graphs I case counts. This is just a bar chart, but because there's so much data that I was using, that's why it looks similar to the ones you would find on like Google if you Googled case counts in Ontario. As you can see, they spiked around early this year, and then around, I believe this was March, both times when we went into lockdown. Again, numerical summaries, again, I didn't include graphs for these numerical summaries because they weren't really needed. So you just kind of have to see where you think the important information is and graph that. I thought there would be a significant difference in between the gender cases, but there wasn't too big of one. So that's why I included this to just kind of show that I initially thought there would be, but to a graph and analyzing it further, there wasn't much. If we keep going down, I used a different method here. This difference in differences. It's a bit of a confusing technique, so I'm not going to go too much into it. It's something that if you're interested in, you can learn, or if you're in stats and you're interested in taking a course similar to survey analysis, you'll probably learn it there as well. Again, these assumptions are related to the difference in differences technique I use. There's some assumptions that need to be met in order for you to be able to use methods. Additional assumptions I made on my own. And then this model has to do with the difference in differences technique. So my last report, I used t-tests, and this I used multi-level regression. Again, regression is a very statistically related topic, so I'm not going to go too much into it. As you can see, so I don't think we have time to cover all of that. But again, if you're interested, there's a lot of like links that go into beginner like regression or beginner stats that you could also look into. Here I'm just comparing the numbers. Again, I'm not going to go too much into them, but the overall result was that close contact cases, just show you right here. Close contact cases, you can see we had 201,000 cases. They're recovered, but we still had 201,000 cases. We still have 3,000 active, 815. You can already tell that's the largest number out of the three. So already we kind of see that those are the most concern. Here I go more into the numbers and explain them. Again, I'm just using I'm just seeing which, so here, I'm seeing which variables affected the cases most. So seems like being male meant you were being male contributed to people having more having COVID. If like more males had COVID than not, sorry. That was kind of outlined in all three. And then just an overall conclusion at the end. Again, big chunks of text. I don't want to go through all of it because it's going to take too long, but it's just it's just delving deeper into everything to make sure that the person that's reading the report has enough context and giving them an outline of everything that you've done to ensure that your research is backed up and your report and statistical techniques are backed up to the best of your ability. And again, bibliography. There's no Wikipedia in here this time, I'm pretty sure. But yeah, that's everything. If you guys have any questions, feel free to ask them. But that's basically how you would go about creating a report in R and how to do survey analysis and data cleansing in R. So if you have any questions, feel free to ask them in the chat. Otherwise, feel free to get back to hacking. R tool that's used in the workplace. So I actually used R, not R Studio, but I added an R block code in, what was it in? When I did my first co-op term, it was at PwC. I actually had to use Alteryx, which is a data cleansing and manipulation tool, and we had to use R in that chunk to manipulate it a certain way, because there's tools that you have, for example, Power BI, Tableau, Alteryx, all these tools can only do so much. So when it comes to needing something more powerful, R would be the way to go, or even Python. So I have used it a little bit, but not extensively as of yet. I think once you're in a more, I guess, data science role, then you would use it more. I've only really been in a data analyst role where I'm creating visualizations. I'll stick around for a couple more minutes in case any of you guys have any questions that pop up. Otherwise, feel free to attend the other sessions or go back to your projects, and good luck. Okay, so I'm just gonna assume that there's no more questions. If you do have a question that comes up later, feel free to ping me, or not sure if you can DM me, but feel free to create a ticket or something and just reach out to me or ask it in the general chat, and I'll be more than happy to answer. Have a good night, everyone.